Welcome back, folks. I know it's been quite some time, so we got a nice, quick, short, easy video to get back into the swing of things. You might remember recently I made this massive case trying to make this little power supply of mine portable. You know, it's nice, it works, not quite what I want. Now this is more what I'm thinking of. As you can see, this is much smaller, enable me to keep some of that portability. And with the help of this USB-C module, I can maintain the option of working off a battery or wall power. These use I2C to communicate with the USB charger, whether it's 5, 12, 20, whatever voltage, up to like 100 watts. So I could still get some decent amperage to run solenoids and stuff when I'm doing automotive tests, which is exactly what I'm looking for. So the first thing I'd like to do is make a template, same size as this, so I can just set it on here, make a couple lines, and then dive on in with my cutter. And if you look here, you'll see that's about 72 by, ooh, that looks like 39.5. 72 by 40. Off from the edge, line up our zeros. There's 70, 1, 2, there's 72. So let's just make a line. Doesn't have to be perfect, remember. Now, there's our 72, there's our 40. This is the square that's 40 mils high. Just keep that in mind. Wouldn't want to cut the wrong part out. Make a hole too big. You can't come back when it's too big. Doing this all by eye, folks. Go ahead and cut this puppy out. There's our 72 by 40. Does it look close enough? I hope so. Okay, so here's the thoughts I'm working with currently. I think I want to have this on this side, but I want to have the ports on the bottom, and then in the future when I install the on-off button, it'll be up above the wires. And as I mentioned before, this is all being done by eye, so right about there looks good. Nah, kid, I'll go a little bit more there, and it's close enough, you know. And as I've mentioned in previous videos, it's always good to keep in mind when you're working on projects like this that the bezel will hide all of our sins. Alright, so now it's time to finalize. Get that big chunk out of there. I'm going to use my cheapy cutoff wheel and do a little trimming. Okay, so now that we have the general shape, let's see how it fits. Little too small. Looks to me like all 4 sides are a little too small, so do a little more cutting. Alright, so we're in. Now I just gotta drill the holes to mount the banana plug jacks. My metric drill bits are at work, so gonna have to find the closest matching English one. So now even though I believe 3/8 is going to be too small, I can widen them up a little bit with my step bit. Where exactly do I want these? Well, I think I'm going to put them right about there. Is 3/8 too small? Yes, by a decent amount. Yes, it is. Go ahead and flip this over. So that's looking pretty minty fresh, wouldn't you think? Who knows? I think, me personally, you know, if you asked me, I would say, oh, I think right about there. And then, of course, once that's drilled, it's time for the step bit. Oh no, step bit, what are you doing? Look at that, perfect. The bezel will hide all our sins. Here we are. Now the only remaining hole that needs to be drilled is either going to be on the side or on the back, and that's for the USB port. This can sit in there flat and flush. Then I found a drill bit that was the exact width of the USB-C. So I took that appropriately sized drill bit and drilled 2 holes about as far apart as the USB is wide. And now I'm going to take this bit and drill this out to a perfect fit. Okay, so to be honest, this hole doesn't look as good as I want. But if I wanted my sins to be hidden, then I should have bought a USB-C outlet with a bezel. That's good enough for me. And you'll see with this cable fully plugged in, we've got maybe 1 millimeter of play. Perfect. Go ahead and move on. Alright, so the first couple connections we're going to make is our power in coming from the USB. I'm going to be using this 14 gauge silicone wire, nice and flexible. Alright, so now that's done. I cleaned up my solder joints, made them nice and flush so I can glue this to the bottom of the container. And I'm just going to strip these and tin the ends so that they can go into this receptacle that plugs into the back of the module. So next, I've cut a couple lengths of wire. These are going to be for our output, which of course will go from the back of the ruideng module, however you pronounce it. And these are a couple inches longer than they need to be, so I got a little extra flex for taking the lid off. So I'm thinking I want positive close to the module, like so. Bam, boom, bang. So now we're all ready. Just need to mount this USB receiver in. So my plan, you know, my favorite epoxy, I'm gonna put some on the floor there, maneuver this into position, let that cure overnight, and we'll do some testing tomorrow. All right, so there you go. My epoxy is cured. We're all set to do some testing. USB-C protocol can handle up to 100 watts, believe it or not, which at 12 volts, 100 watts is like 8 amps, a little more than 8 amps. So you can power this now, since it's USB-C, you can power this from either a battery pack or a wall pack. And unfortunately, this wall pack only gets to 65 watts, so I won't be able to fully test this thing today. My battery pack also does 65 watts, so we're just going to jump straight into that. So pop that in. Here we go. Now, let's see. You can see that the USB module has been set properly because we're getting almost 20 volts. Now, these work by communicating with the power supply and negotiating the proper voltage. So there's a dip switch on the front that you set in accordance with this chart on the back, depending on what you want your voltage to be at. All right, so we're all set to do a quick little load test here. You can see the voltage is already at 12 volts and the limit's at 3.1 amps. Turns on pretty slow. No problem so far. Wow. Well, apparently this headlight only takes 4 amps. I thought it was a 5 amp bulb. But hey, it's handling it just fine. And we're on the battery pack right now. So now this brings me to why I chose to put banana jacks in the front of this instead of binding posts or some other connection method. Like on my other box, I just used those battery pack connectors. I can't remember what the abbreviation for them is. But regardless, I went with banana jacks because most test equipment, be it multimeters, I mean, pretty much everything except for oscilloscopes uses banana jacks. So that's why I went with it. This is my AES wave terminal kit. Every single one of these runs off banana jacks, so it fits in much better with the rest of my test gear. Now, as a quick example, I have this defunct Ford vapor blocking valve that I'll do a quick test on to demonstrate how this might actually be used by me in the field. So now imagine you've got the car up in the air, the ignition is off. You take this off the car, take a peek. Oh, those look like 2.5 mil flat. So we hop right over to the kit, 2.5 flat, but we want female. We need 2 of them. And we got these banana jumper leads off the power supply. We're gonna hook right into them. The voltage on the power supply is already set to 12 volts. Current limit's at 5, which is around the max that this power supply can handle. I'm just going to leave it there. This is just a regular old solenoid. Power it on. Oh, and you can hear something's operating in there. So the solenoid works, but does the valve. So I'm going to blow through this while turning the solenoid on and off, and that way we'll determine if this actually blocks vapor or not. Uh-oh. Sounds to me like some vapors getting by. So we can go ahead and keep this off the car, because we're going to need a new one. So that's just a quick little example. But I'm going to end it there. So hope you enjoyed. See you next time. Oh no. Oh no. That's fine. I don't know what the hell to call it.